Okay, this is the review, and this is going to be video on scenario 4 and 5. So the average sale price of a single family house in the United States is $243,756. So our mean is 243,756 with a standard deviation of 44,000. Draw the population distribution. Within what range would the middle 68% of the houses fall? So since they gave us an apps and they gave us a percent, we're probably going to be working with an inverse norm. And we know we're working with the middle, so this is going to be centered. So my drawing is going to look something like this. This right here is going to be 68%. And we're going to look for a lower and we're going to look for an upper. And we have mean right here in the middle is right there in the middle of the 243,756. Because they gave me the middle, we're working with an inverse norm. So inverse norm, which in this case is going to be, the first thing is going to be 1 minus 0.68 over 2 because we're working with the middle. Mean of 243,756. And then 44,000. Did not give myself much room. So second vars, inverse norm, parenthesis, 1 minus 0.68 divided by 2, mean 243,756, standard deviation 44,123, 44,000. This is going to give me my lower bound. All right, so my lower bound is 199,999.8528. So 1999.8528. This is the only thing that you put into the Google form. All right. The upper bound is going to have the same graph, and we're still going to be working with the inverse norm. However, we need to calculate the upper bound, which is going to be 1 minus the 0.68 over the 2 plus the 0.68, mean of 243,756, standard deviation of 44,000. So second vars, inverse norm. Already have the 1 minus 0.68 divided by 2. I just need to come back and add that percent back. So add plus 0.68. Mean of 243,756. Standard deviation 44,000. And I end up with 287,512. .1472. And that's my upper bound. All right, so this is what you'd put into the calculator. And yes, you need to take it all the way to the 4 decimal places. Now it's asked for the probability. So it asked for an app. So I'm either going to be looking at a norm CDF or a stats test. What's probably a random sample of 4. So since n equals 4, it's probably going to be easier to do a stats test. Have a price of more than 275,000. So if I'm drawing my picture, 243,756 is my mean, 243,756. I want to know probability that it has more than 275,000. And we're shading up. All right. So mean 243,756. Stats test, z-test. It asks for the mean. Then the next thing it asks for is the standard deviation. Our standard deviation in this case was 44,000. thousand. Then it wanted to know what the average was. The average of the sample needs to be, was the likelihood we get 275,000. And then our sample was size 4, and we're shaded up, so that means it's a shade greater. So here we go, plugging in that information. 275,000, 44, excuse me, that's not right. This needed to be 243,756, 243,756. Standard deviation 44, 1, 2, 3. X bar of 275,000. Sample of size 4. And we shaded to the right, so we need to make sure we choose the greater than. And when we do that, we're going to get the probability that Z is greater than 1.4201, and that equals 0.0777. And the 0.0777 is what goes into the Google form. For those of you who prefer the norm CDF, we could have done a norm CDF. Norm CDF would be lower bound, and I'm just going to 275,000. Upper bound's positive infinity. Mean is 243,756. Be really, really careful with the standard deviation. The standard deviation is going to be 44,000 divided by the square root of 4. So if I'd done the norm CDF, second vars, norm CDF, lower bound, the lower part of my shading was 275,000. The upper part of my shading was infinity, and you better have a whole lot of 9s on this one, otherwise it's not going to work right. 243,756, standard deviation 44, 1, 2, 3, divided by the square root of 4, which I just do 4, then the caret, and then the 0.5. And there we go, 0.0777. All right, so essentially the same answers. What is the probability that a random sample of 16 houses has an average price of less than 236,000? So since we're doing a sample of 36, and we're talking about the average price or the X bar, probably going to be easier to use a stats test since we're only looking with one number. So with that being the case, my mean 243,756, and we want to know less than 236,000. So we're shading this way to negative infinity. So mu equals 243,756. Standard deviation is 44,000. X bar in this case is 236,000. N is 16. Shade left. Stat test, z-test, mean of 243,076, standard deviation of 44,000, 236, 1, 2, 3. X bar in this case was 16. And we shaded to the left. And we get probability that Z is less than negative 0.7050 equals 0.2403. 0.2403 that I box is what goes in a Google form. Had you preferred to do the norm CDF, it would look something like this. Norm CDF, norm CDF, the lower bound, negative infinity. The upper bound, 236,000. Mean, 243,756. and our standard deviation. And you have to be really careful about this because we're talking about the average. So since we're talking about an average, we're going to have to take the 44,000 and divide by the square root of 16. So when I go about doing that into the calculator, second bars, normal CDF, lower bound, negative infinity. So load this up with a bunch of nines because we are working with big numbers, so you're going to need a whole lot of them. My upper bound, 236, 1, 2, 3. My mean, in this case, 243, 756, and 44, 1, 2, 3, divided by 16. Make sure you use the square root button, the caret button, caret 0.5 raised to the half power. And we get 0.2403, which is what we previously got. So if you prefer the norm CDF, that's great. All right. Draw the sampling distribution for a sample of 25 houses. Within what range would the middle 68% fall? This is tricky because now we're working with an N of 25. All right. And so I'm going to draw the picture down here a little further down where I have a little more room. So in this case, we have 0.68. We have our mean of 243, 756, and we are looking for the lower and the upper. All right. Now, in this case, they gave you an app. So since they gave you the app, you know it's going to be an inverse norm. And since the center, you're going to have to do a 1 minus. So you're going to do 1 minus 0.68 over 2, mean 243,756. But since our sample is size 25, our standard deviation is going to be 44,000 divided by the square root of 25. 44,000 divided by the square root of 25. So second bars, inverse norm, parenthesis, 1 minus 0.68 divided by 2, mean 243,756. Standard deviation in this case is going to be 44,123 divided by 25 raised to the half power. And we end up getting 235,000 equals 235,004.7706. So that's one way to do it. And then you're going to have to do the same thing for the upper bound. A much faster, since it's centered. This is so much faster. I highly recommend it. All right. Stats, test, Z interval. Stats, test, Z interval. Stats, test, drop down to number 7, which is Z interval. Standard deviation, 44,000. X bar is, what's our mean? 243,756, 243,756. Our sample was size 25, and we're using for a level of 0.68. And there, right there, we have our answer. All right. And we just go to the number of decimal places they have. So our lower bound, 235,005. So this is your lower. And we just need to box that. Please don't use the comma. And then the upper is going to be 252,507. And that's my upper. Much easier way to do that. Much easier way than using the inverse norm. Yes, you can use the inverse norm, but stats test Z interval is a lot better. I'm going to do that one more time. Stats test number 7, which is Z interval, standard deviation of 44,000, 243,756 was my mean. My sample was size 28, and my level, or my center part needed to be 0.68. Okay, so that one's a lot easier to do using that. Moving on to number 5. It says give the mean of the sampling distribution. I always like it when they ask that question because it's really easy. The mean is whatever the mean was. So let's read this. So I can't even say that, is a scientific name for their commonly called hummingbird. The hummingbird lives on the West Coast and is named for C.A. Allen, who studied these birds extensively. Based on the information from the hummingbird book, the mean incubation time for Allen hummingbird eggs is 16 days, so the mean is 16. We'll assume the standard deviation is approximately 2 days. Suppose that we have a random sample of 30 eggs in the incubator. So we have a standard deviation of 2, N is 30. Okay, we don't know if it's normal or not, but because this is 30 or larger, we're good to go. So given the standard deviation of the sampling distribution of X bar. So they're not asking for the standard deviation of the pop, they're asking for X bar. Standard deviation for X bar, look for the X bar, or look for the standard deviation sampling distribution of the X bar, the mean, or the average is the standard deviation of the population divided by the square root of n. So in this case, 2 divided by the square root of 30. So 2 divided by 30 raised to the half power. And once again, I like to use the caret button. All right, 230 raised to the half power. And I end up getting 0.3651. All right. For this 30, find the probability that 16 is less than X bar. Be careful, this is an X bar, and 17.5. Now, I'm going to tell you, anytime they give you a range like this, probably better off doing a norm CDF. Yeah, it's a little bit of work, but it's probably better off to do a norm CDF anytime they give a range. So I'm going to draw my picture. And they tell us the mean is 16. So the mean is 16. And we want 16 to 17.5. So we're actually looking for that value right there. All right. So we're looking for the mean all the way to 17.5. So the way I would go about doing this is with a norm CDF, because they gave me a range. I had to work within 2 values. A norm CDF, my lower bound being 16, my upper bound being 17.5. My standard deviation, my mean itself is 16. And my standard deviation is 2 divided by the square root of 30. All right. So, and I'm going to do this 2 different ways. Second vars, norm CDF, lower bound 16, based on our shading, upper bound 17.5. Mean happened to be 16, and our standard deviation was 2 divided by, and as you know, I like to use the caret button. So 2 divided by 30 raised to the half power. And I get 0.4999. Now, some of you are going, hey, couldn't I have used the 0.3651? It would have been close. It would have been close enough. So second vars, norm, CDF. And if I had just used the standard deviation that I previously calculated, 0.3651, it's going to be really close. It's not going to be exactly the same, but close enough. All right. So that right there concludes the review. If you know this, then you'll be good for the test on either Thursday or Friday.